So let's try and use our calculator to do the work here for this one. Now in this case we have a consumer agency randomly selected auto drivers who had similar driving records, cars, and insurance policy, and the provided table gives the monthly insurance premiums in dollars by these drivers insured with one of 4 insurance companies. So we have data from each of these 4 insurance companies. So what we should do before we go to ANOVA on our calculator is we should enter each of these into a separate list. So in this case, notice we'll have 4 lists, one for each of these 4 companies. So I'll enter all the State Farm data into one list, I'll enter all the Geico data into another list, all the Farmers data into a third list, and then all the AAA data into a fourth list. So here we'll get 4 lists. And once we do that, then we can perform the ANOVA test. And in this case, because we're comparing 4 groups, our null hypothesis will be that the means of these 4 different insurance companies are equal, right? And the alternative is that one of them is different. Now, take a moment now to go ahead and enter all of these data for each of these 4 separate insurance companies into 4 separate lists in your calculator. Okay, so for instance here you can enter all this data into L1 for this run, enter all this data into L2, enter all this data into L3, and this data into L4. And once you do that, then you're going to go to your test stat tests, and then at the very bottom of the list you'll see ANOVA. Okay, and then in this case you'll enter those 4 lists that we entered all that data into. And make sure that when you do this, you're separating each of the lists with a comma, using the comma button, which is, if you remember, the comma button is right above the number 7. So make sure you use that comma button to separate the different lists. Okay, and once you do that, it'll give you everything we need here. So for instance, it'll give me the test statistic. Okay, so try and if you need to pause the video and enter all these values into the list, go ahead and do that. And once you do that, you should run the ANOVA test and get something that looks like this for the F score. Okay, so that would be maybe I don't know, somewhere around here. And then for the p-value, which gives us the area under that F distribution, we get something around 0.1142. And in this case, we were testing with a significance level of 0.05. So this is bigger than our significance level, and so we are not going to reject. We're going to fail to reject. So here the p-value was 0.1142, which is bigger than our significance level of 0.05, so we're going to fail to reject. And so the conclusion is that now, since we're not rejecting, there's essentially not enough evidence to support the claim that any of these come from populations that have a different mean. So there's not enough evidence to support the claim that one of the companies has a different mean. One of the companies. In other words, if it's very possible that that these four groups come from populations that have the same mean. So yeah, it's possible that all the means are the same.